Hello guys, Winston here. If you've ever paid attention to my video titles, you'll notice that they usually end in a number. That number is something I assign to projects in a roughly chronological order, depending on when I get around to offloading footage from my SD card to my computer. The order in which I release videos, though, generally has nothing to do with those identifiers. Some projects simply take longer than others, so they get released out of order. Some projects get indefinitely put on the back burner because I don't feel like I have enough substance to tell a good story with it, and some videos get shelved entirely because of a failure. It could be a bad fundamental assumption in my planning, or a catastrophic machining error, or a failure of my determination. It could be a combination of all three. Usually, I don't talk about projects that don't see the light of day because there's no narrative there, but given that so many of us right now are counting on small victories to get us through the day, I wanted to make this video to sort of remind ourselves that failures in the shop are okay, and sometimes I actually need a good setback to reset myself and get my mind back on track. So here's the summary of how I screwed up my last project. About 2 weeks ago, when it became apparent that the White House and CDC would issue an official recommendation to wear a face covering of some sort in public, I decided that I wanted to take a stab at producing a mask. One of my good buddies, George, over at Maker's Best Friend, made me aware of several designs for 3D printed masks that were circulating in the community. But comfort and fit issues aside, the biggest problem that I saw with these designs was the print time. One person with one printer could only make a few of these a day. That's fine if you're making these for a household, but if you want to make an impact at a local level, you need way more throughput. I wanted to vacuum form masks, which in my mind would have several advantages. One, vacuum forming is fast. Not injection molding levels of fast, but you could have a substantial portion of the work done in minutes and not hours. Once I'd machined a buck, I could not only vacuum form masks rapidly, but I could also trim them out on the CNC with appropriate fixturing. 2. Vacuum formed masks would use way less material than printed masks. There would still be some waste produced, but the material stock used in vacuum forming would be much easier to recycle. 3. These masks would be smooth, which makes them far easier to keep sanitary. You can wipe them down with a cleaning solution and not worry about contaminants hiding in the nooks and crannies of printed filament. And 4. Depending on the thickness of the material I chose, I could achieve a certain amount of deformation in the mask so that it could conform to different face shapes better without having to rely on gasket material or adhesive-backed foam, which were fast becoming hard to source. Simple masks like these work well enough in most cases without the ultra-compliant molded seals in respirators. After a couple days of sketching things out and mulling it over in my head, I started CAD modeling. Thanks to the existence of shared Fusion files from other collaborative efforts, I was able to learn from other people's CAD models. I had never made a mask like this before, so I wasn't quite sure how to make something with the weird shapes and contours that I was seeing. This particular mask design here was made by drawing multiple cross-sections of the desired profile and lofting through all of them. To me, that seemed really inefficient because if you wanted to change the shape in any significant way, you would have to tweak multiple sketches. I decided to create 2 sketches to loft between and then use some perpendicular sketches to create rails along which the loft would be guided. I then made a cut from the side to approximate the shape of some of the other mask designs I was working from, and to soften the edges against the face, I created a swept flange along the 3D profile of the mask. However, when I tried to combine this swept feature with the rest of the mask, Fusion really did not like it. I honestly have no idea why this failed, but if anyone knows how I can appease the T-spline gods, please let me know in the comments below. Regardless, this was but a minor setback. I really didn't need a unified mask model, just the shape around which I could form a buck for vacuum forming. I extended that swept flange to form a larger brim. This would provide me some additional smooth real estate for the vacuum-formed plastic to lead into the mask profile, hopefully minimizing wrinkles in the plastic. It would also make it easier to create the mold model since making it would be a simple matter of splitting a large volume using the body of the mask and the swept features. To machine my mold though, I would need to stack up several layers of MDF, so I projected and cut several cross-sections of my buck. I designed the buck to be easy to attach or remove from my fixture for machining. This way I could not only use it for vacuum forming, but also to hold the masks in place on the CNC while I trimmed it from the rest of the sheet it was formed from. Knowing that I didn't have a long enough tool to surface the entire buck at once, I created 2 sets of toolpaths so that I could build up the height of the buck progressively. I thought catting this up would be the hardest part of the project, but it turns out the machining was where I got served. A combination of haste and errors completely wrecked my plans. First off, on my base fixture, I counterbored the wrong side of my MDF. The screws holding my buck to the fixture plate were supposed to be recessed, so that meant I had to use my fixture upside down. The screws holding my fixture to the wasteboard were supposed to be counterbore, but the counterbores were on the wrong side. There was not enough material to counterbore from the other side. Then I screwed up the most fundamental part of using a CNC, setting your zero. I made my fixture plate slightly larger than I needed to so that I could use the touch probe in the lower left corner to locate my zero. That's how I set it up in Fusion. But because of the extremely low helix angle of the Amana downcutting end mill I was using, I didn't clock the cutter quite right for it to touch off on the walls of the probe properly, so the zero I found wasn't actually on the corner. That mistake led to me shaving off a bit of the screw holding my fixture down. Luckily, this end mill survived without so much as a chip. I credit that to the relative softness of the stainless steel fasteners, and maybe a little bit to the quality of the cutter. And then, during the 3D finishing of my bottom layers, I ended up with a step in the finished surface. I had no idea what happened, I thought maybe I'd missed a step, but after I slept on the problem and tried to run a slightly lower finishing pass to erase the mistake, I discovered two things. One, when I had assembled my HDZ months ago, there was a tiny bit of slop in the ball screw. The bearing blocks on either end weren't tightly capturing the ball screw, and the spider coupling between the stepper motor and the ball screw was in no position to stop vertical slippage. The Z carriage and the ball screw were essentially floating between the bearings with about a millimeter of slop. The finishing strategy I employed resulted in a ton of Z direction changes, and so what you're basically seeing is a massively exaggerated backlash. Issue number 2 was that I was getting a lot of chatter in some of my MDF cuts and I couldn't figure out why. After giving my spindle a bit of a wiggle, I felt some play and found a loose V-wheel in the bottom left corner. That seemed innocuous enough, so I tweaked my eccentric nut, got the V-wheel snug against the rail again, and kept going. But an hour later, it was loose again and I was out of adjustment on my eccentric nut. The wheel just would not grip the rail. And then I decided to check the upper V-wheel and found that it had cracked, splitting perfectly down the middle. But it was still held together by the bearing, so it was really hard to notice this when it was still on the machine. Those accumulated errors made it impossible to recover my mold and end up with a single smooth surface for vacuum forming. Because the HDZ had not been held securely in a perfectly vertical orientation, the tramming job I had done on the spindle before this project could not be trusted. Furthermore, if my HDZ had been crooked going into this project, that meant that the coordinates of the tip of the end mill relative to the homing switch would be different now. Restoring the perpendicularity of my Z-axis to the X rail would mean that my X-axis 0 point would no longer be valid. And because I had used my touch probe incorrectly earlier, it would be nearly impossible to perfectly reacquire that imperfect 0 coordinate that I had started machining with. So the final layers of my buck ended up with a catastrophic lateral offset, and at that point, with dwindling inventory of MDF and the prospect of having to remake the mold and then still having to design and machine a vacuum fixture, I decided to call off the attempt to prototype a breathing mask via vacuum forming in a relevant time frame to be useful during the current pandemic. I'll probably come back to this concept eventually, but for now I'm walking away from it. There are times where I nail the project on the first try, which is surprisingly often, but there are also plenty of cases where the stars of misfortune align all too perfectly. So why am I sharing this? Well, for starters, I think there's still some validity to this approach, but more broadly, I want to encourage people to try attacking a problem from a different angle. This could be using a different material or a different manufacturing technique. Creativity is paramount if we're going to fulfill the promise of the so-called personal industrial revolution that we began years ago. Makers everywhere are already doing an awesome job helping our healthcare workers in meaningful ways, but we're still running into the same problems that larger companies are: supply chain limitations. People can't get their hands on enough PETG film, elastic bands, or polycarbonate sheets. If there are places where material shortages can be overcome with alternative solutions, we need to find them. But altruistic motivational blurb aside, I'm setting this project aside for my own mental health. I had a week-long sprint phase where I tried to make this work, but now I need to step back and take a bit of time to get over the disappointment of my failure and focus on a different creative venture. I have this mentality where I will set out on an unconventional strategy. Usually it's high risk and low reward, which is a terrible business model but a great exercise for the mind. Perfect example, WorkbenchCon 2019. I was a finalist in the Home Depot Toolmaster Challenge where people raced to build a cart in the shortest amount of time. I was the last person to attempt it, and after watching all the other contestants struggling to assemble their carts in a certain order, I tried to work backwards. And it backfired spectacularly, because I ended up reversing a component at the beginning that screwed me over in the end. but if I was going to lose, I wanted it to be on my own terms. If I tried to play the same game as everyone else, I would probably lose and feel zero satisfaction. I'm sure I'm not alone in having moments in my life where I wished I'd broken the mold and tried something radically different. I didn't want to leave that stone unturned, and that's why when I saw 3D printed respirators, I immediately tried to come up with an alternative. This time though, I came up short. This isn't a competition by any means, but I think the window of opportunity where a physical prototype emerging from my garage would have been useful to anyone has ultimately passed. So instead of moping about my failed project, I'm going to take advantage of the first glimmer of genuine sunshine in far too many days and try to enjoy a ride around the block on my sweet aluminum longboard. I want to thank you all very much for watching, and I hope that some of you will be inspired to try something different, and to be okay with failure, because sometimes it's worth having walked the path less traveled just to see what's there. I'll be back soon with more CNC projects and DIY nonsense.